Hi guys, it's been a few weeks since we got our solar array set up back here, and now we need to get back to our battery storage for it and the charger and all that equipment that's going to collect the power. And we put that into a computer server rack. Now it's time to get around to making that a full assembly. Okay, here's the computer server rack from our previous video. I'll link that in the description if you want to go back there and see what that's about. But essentially, this is a used computer rack. It's heavy duty enough that will hold the batteries that we intend to put in it. We're going to use 99-pound server rack batteries, and they're 48 volts, so this will be a 48 volt system. And right now we just got to take all these parts and put them back together so that we can get the components installed in here. Okay, we mounted all of our parts to this Hardy backer board. It's basically a fireproof material, so that seemed like the best option to go. It's a little on the fragile side. We reutilized some of the brackets that were in the server rack, cut them down, drilled holes in them so that they'd be suitable for actual support mounts in here. Got it? And the bottom of the backer board is supported with a homemade bracket out of some aluminum angle, and that'll just go down at the bottom here. Then we have this middle support bracket that was also a piece that was repurposed from the rack, and just cut it down and add screws as needed. So we tried to reuse as many of the pieces from the rack as we could. This is the mounting bracket for the inverter, and it just goes on up here, and it goes completely through the backer board and into one of the supports that we repurposed. Okay, now we have a place to rehang the inverter. Okay, this is a pretty heavy little unit. Two screws that hold this cover on. And all the connections are done up in here. And we can see if our mounting holes are lined up, because this is where we originally had these screws to hold everything together. this is the place where we chose to mount the charge controller, and we have room that we could mount several more of them above this one if we wanted to. So we left this to be expandable. Okay, below all that we're going to mount this Lynx 1000 power in. This is basically just a 1000 amp bus bar, but it makes a lot of connections easy. You'll notice that if I put it in, it's upside down, but for you OCD people, they did include a decal so that you can change the direction of it. This is an interesting item, this bus bar. It has these dividers so that you can run your negative cables into this bus bar here, and then when you flip this cover down, your top cable for positive will run over and connect into this bus bar here that's marked with the red. Additionally, if you buy the 8mm screws and nuts and some washers, you can assemble a terminal into this position, and then you can put fuses across these. So it just extends it if you want to go that route. If you look up a hack on this Lynx bus bar, you'll find the details on the lengths and size of these screws. It's not really hard to figure out. It's just a duplication of what's going on down here. Remove the screws for this cover. You can get underneath and put these bolts in. See the other top one?
Yep. Just a second here.
So we got this little fuse block here with 2 circuit breakers in it, and so we're going to split the output of the inverter into 2 different circuits. Okay, and the last of the main parts that we have is a couple of outlets that are going to be in this box. And I made a spacer out of the hardy board to go back behind this so that this hole would line up with the one in the fuse block. Okay, now we're on the opposite side of the server rack, and we're going to install these shelves for the batteries to set on. And I may have mentioned this in our previous video on this cabinet that you want to be sure you get these shelves, because it can be pretty expensive buying a set of them if you don't have them, or you're forced to fabricate some. So it's a good idea to make sure the cabinet you try to find has these shelf brackets. The brackets installed just by putting these clips into the rack. Okay, we repack these for the trip out to the mountain, but this is pretty much the way they come from the factory. There's some mounting screws to hold the battery into the rack. That's the battery itself. And then on each side they've provided pre-made cables for tying them all together in parallel. Okay, so here's the battery front. You've got the terminals for the positive and the negative on it. There's a breaker switch here which turns the battery on and off and also serves as protection. Then you have connections up here for hooking the batteries together if you have some kind of external management system, or you can also access them with your computer to check any kind of functions in the battery. And they show you state of charge if there's any alarms on it, and then it's got a switch on it so that you can set each battery independently so that they can be identified in your parallel setup. Okay, we got one battery installed and it doesn't really line up with the mounting holes, so we're probably going to end up putting like an 1/8 inch spacer on these rails. Probably get some plastic or something that can be laid on there, and then that'll raise this up where the holes line up and the mounting hardware can be used. But these aren't going anywhere. We got our next two shells put in, so all we have to do is load the battery on top of this one. Okay, there's the second battery installed, and there is room to install 4 more batteries in the rack, so we can have a total of 6 in there. Now we just take a couple of screws out of the bottom of this and remove the service cover for the inverter. We have 2 screws to remove from the bus bar. These protective covers can come off. Move the cover from my breaker box. Now remove the cover from our outlet box. Took the charge controller back out of the system because I remembered the other day that I had not yet set this little switch down here, and since we're going to be using lithium-ion batteries, that has to be set to position number 7 according to the booklet, and it says that then it will give you a blink sequence out on the front panel here, but you don't see that until you're connected to the PV connection, so we don't really know if we have it set right until we apply power with the solar panels. Okay, I'm making up my cables here that are going to go from the solar charge controller to the bus bar, and I went ahead and tinned the ends of these wires. It's really difficult to get them up inside of the connector on the charge controller the way they are. Usually they intend to put ferrules on these things, and I don't have any ferrules that big, so just a little bit of solder in there holds it together and they go into the connector. And I've been using this crimping tool for crimping welding connectors, and I usually like to use it in a vise because then you can just squeeze it and get a pretty controlled clamp on it. But you just smack the top of this thing with a hammer on a sturdy surface and it does the job, so that's what I'm using. And then I got this kit that has all the lugs in it. What I like is it has these shrink tubes, and they have the clear adhesive in them, so when you shrink them down you can see the glue come out of it, and it really holds everything together nice and solid and gives it a finished look. That smashes them down pretty good. They don't pull off. It's a good solid connection. Okay, here's the connection we have done so far. We got the primary wires coming out of the inverter. So this is the 120 volt output. And then that's going to travel down. And it goes into this breaker box where I've got two 15 amp breakers. So I have this black wire. It's feeding both of the breakers. Have a jumper going in across there. The red wire is being used for the neutral over here. And then I've got two white wires down at the bottom. They're going into the neutrals of these outlets. And then there's a black wire off of each of these circuit breakers that goes in to feed each one of these outlets. So it's pretty standard wiring down in this part. Okay, this is the positive battery wire, and I identified it with red shrink tubing, and that's because I'm using black welding wire here. And this was number 2, which is big for this, but it doesn't hurt to go oversize. And that's feeding into our positive bus bar here that is denoted by the red on it. And same thing with the negative, black on this side, and that's hooked into the black bus bar. So we've got our connection for the battery. And then over here on the charge controller, we got these heavy cables coming over here. Red one's feeding the positive, black one's feeding the negative. So all the positive and negative are hooked together. I drilled these 2 holes through the hardy board, and that's where the cables for the batteries are going to come through. And I made up a couple of cables. Both of them also out of welding wire, so I've identified them with red and black shrink tube. And just for added insurance, I also put some of this flex tube loom on here. That's just a split material, and it just put over the wire and covers it up. I'm not quite sure what I'm going to do here yet, but this is the connection for the PV or the photovoltaic. The solar panels attach here. So I had some leftover MC4 connectors on wire, so I put that in there, and we'll use that to test the system. I'm making sure that I get the red wire on the positive terminal that I've identified with my shrink tubing. And then the negative cable is going to go on the opposite side on the negative terminal, but I left these battery wires long because as I build my pack, I want to keep this one down in this corner of the pack, and then the opposite one is going to be up in this corner, but as I add batteries, it'll just continually be moved up on the other side. You could do the same thing with the positive wire on the other side and do vice versa, but this is the way I'm going. And that ensures that the draw from the batteries is about as neutral as you can make it. Short of adding bus bars to this thing, this is about the easy way to go. Put the inverter cover back on. Okay, I am going to modify this bus bar in here and put these screws in. There's already places for the same type of bolts that are in this place. Just have to remove the plastic inside with these screws, and that comes out. Put the bolts in. Then it's possible to have a bridge that you can put a fuse in here. So these wires that I have on here currently are going to be moved up so that I can put the appropriate fuse in there. So for right now, we're going to put the cover back on. Okay, we're underneath of our solar panel array, and it's time to get serious about seeing if our solar generator can be charged. So what I need to do is I'm going to connect two of the panels in series and the other two panels in series. And then I've got this pair of connectors here which will put those two series arrays into parallel, and then we can use that to get the power back to the generator. Now I have my two combined parallel arrays here. So we got 4 panels, 2 series, the other 2 are series, and then adding those together in parallel. So this will be the final output on these 2 lines here. Okay, we're going to use our gauge and check the voltage in our panels. Right now we're showing 84.5 volts DC on our array, so that looks about right. According to the panel specs and the sunlight that we have. Eventually we're going to have conduit running up to this, so I'm going to temporarily mount this box on here. Quick way to put threads into a pipe is to use these nutsert. Got to drill some 3/8 inch holes for a 1/4 inch screw. There's a number of different ways to put these inserts in. But there's a tool, has a knurled base on it, and then just a hardened bolt. You thread it onto the tool. Hold the base part of it stationary and then just turn the bolt. It breaks off the base part of it and pulls it up inside of the sleeve like a wedge, and basically the harder you pull on these things, the tighter they grip in the hole. Just ran a couple of wires from the panels up to the controller, and we got a blue light on that right now showing that it's doing a bulk charge. The inverter is on and it's showing that it's running. Batteries are turned on and they were shipped half charged according to their indicator lights, and right now the third light's blinking on both of them, so it's getting a charge right now. Okay, I got the Victron app for the charge controller coming up here, and we have 825 watts going in right now, and down here you can see we got almost 15 amps of current going into the batteries. And this is without the panels faced in the right direction, so it's doing pretty good for early morning sunlight. So far in just about an hour, we've got 710 watt hours that have gone into the batteries. In contrast, here's our two solar panels. These are used 265 watt panels, so they're probably 240 watts each by their age, but right now we're getting 256 watts on them, 255, and that's putting 9.4 amps into the batteries. We got two marine batteries that goes into. They're old batteries, and they've been degrading over time, but for the general use that we have around here, it's been plenty. But there's always been things that we've wanted to run that we could not. So now we have the capacity to pretty much use anything that you can pull from a wall outlet. To move our solar array, right now I just have these two bolts on this collar. Loosen those up. That's a pretty simple one-hand operation to move the panels. We've been using this little Honda generator for a lot of our electrical needs, and it reliably ran a jackhammer for busting holes through rock, but one thing it was not able to run was this table saw. It just refused to do it. So plugged into our new solar system. And other than fans coming on in the inverter, that started up without a single hitch. And a handy device if you're working especially with solar systems where you need to know how much current a device is using. This kilowatt meter that I have plugged into the outlet, it's upside down of course, but it shows that we have 119.5 volts right now, which is consistent with what the meter said. And it will tell you things about a device as to how much power that it uses, how much amperage it draws. So it's a good little item to have in your kit for checking electrical things. We've got 1,000 watts coming from our solar panels right now, and down here it says it's the charger's feeding a current of 18 amps into the batteries, and up here it says we have 15 amps coming from the solar panels. So that's basically what I bought this Southwest meter for, was so that I could check my amperage. And right here you can see that it's set to AC by the sine wave. Press that and it shows the symbol for DC voltage. And right now it's showing me that I have 14.8 amps coming from the solar array. Well, it's 12:40 on the first day of running the solar system, and the batteries have gotten out of their three-quarter state of charge and are now going towards the full charge light. The app is showing right now that we have 3.5 kilowatt hours that has been yielded already today. Alright, the panels aren't in a really good location, so some trees are shadowing them right now. And during the summer it doesn't really get to that, so that's why we put it where we did at the time, because that's when we mostly will be using this for the time being. But right now it's 2:10 in the afternoon. We're not showing any watts, but we have 86 volts at the solar panels, and the voltage in the batteries right now is 53.48 volts, and it's showing fully charged on the battery face with the LED indicators. So we look at the history, says we got 4.07 kilowatt hours today, and that's just going from about 10 o'clock until 2 o'clock, so it's not too bad. Okay guys, hopefully you made it this far to the end of the video, and you can understand that we're going to add more batteries to this unit. We're probably going to add some kind of a heater in there to make the lithium-ion batteries survive cold temperatures. Then there will also be plans to install the fuses and breakers that are not in it yet. So this is an ongoing project. Thank you so much for watching. Thank you for subscribing. There's a lot more to